Okay, I think we can get started. So I'm Omi. I'm a co-founder at Fragment, which is a double entry ledger as a service API. And so we've been using QLDB as a core of our ledger, and we give our customers a double entry ledger so that they can don't have to sort of build it themselves. But this talk is basically what I learned in the last sort of 6 months. We started in January. I didn't really know much about ledgers or QLDB or anything. And so this is everything I learned about QLDB when I built like a production quality ledger on top of QLDB. So the talk is sort of structured in a few different areas. We're going to look at a use case to sort of guide us through how to solve a problem. And so what we're going to do is we look at a sort of business problem. Then we'll actually go look at how a double entry system works, and I'm so tired. We'll sort of start from the very basics of just how we think about money, why a double entry system works the way it does, and then we'll come back to our use case to implement that use case in a double entry system. And then we'll dive into, okay, if I want to implement this ledger design, how would I do it in QLDB? Or what are some of the sort of features that QLDB has to help us go and do that? So the use case is, I feel like this would be something that actually would happen in the future, which is buy now, pay later for space. And so this is like a business where they take people to space, but you don't have to pay up front. They finance that for you. And so I think for that type of business, a ledger would be pretty interesting. They are having a space program, launching stuff. They are also a financial company because they're making loans to their customers, and they make profits on not just the launches, but also the loans they give out to customers. And so if you have this use case, like how do we break it down into a ledger and the ledger entries that would go into their ledger to sort of track all those payments coming in and out of their business. So let's start with how do we think about money? I'm not sure how many people are familiar with ledgers. I had a very vague idea of what a double entry ledger was when I started all this. So this is sort of how I thought about, okay, what do accountants do all day? And so the kind of idea that we have of money is sort of what we think of money as kids. Once you get into financial systems, you're like, oh, wait, money is really weird. But we have an intuitive sense of money, which is that it's some like pocket money our parents give us. So that's how we sort of first learn about money usually. And it's this thing that is like immutable. You can't split a penny. You can pay people. You can't create it or destroy it. It just sort of moves around the world. And what a ledger does is to take that sort of intuitions that we have and put it into a data structure. And it encodes those rules so that most people implement a ledger on top of a database. The database lets you do a lot more with data than you can do with money. And so a ledger is structured in a way that it tries to make sure that those rules about money, that you could only move it around, you can't create it or destroy it, you can't split things up, those are enforced. And so the sort of view that we have with money is that you have like boxes of money, you put money inside them, and you can like move things around, right? And so there's current state of the world, which is how much money I have. And then if you want to go figure out what did the past look like, you would maybe have a sort of table of here are all the things that could happen. And the most important thing about that table is you only add to that table, right? So that something happened in the past, always happened in the past, and you can never change the past. And so a ledger sort of has this dual view of what's the current state of the world today and where is the money now, as well as where was the money at every given point in the past. And so we have this unit called, say it's a cent or a dollar, and that represents some wealth that you have. We also have another unit, which is an IOU, and that represents sort of the opposite of money, where that is money that you don't have, but you owe to someone else. And sort of those two units are like negatives of each other, and a ledger needs to represent sort of both of those ideas of just wealth that you have, but also wealth that you not just don't have, but have an amount of. But those IOUs otherwise are treated like money, when they only get moved around. You can't create or destroy them, and sort of in the data structure, they're treated very similarly. And sort of the only rule is that when you're trying to like figure out what the current state of the system is, when you add those money and IOUs together, one is a negative of the other. So it's pretty intuitive if you think of them as positive and negative numbers. In this talk, I won't talk about credits or debits, and because I think that accountants use credits and debits because accounting was invented before negative numbers. And so I think we grew up with negative numbers. I think we can handle just having a ledger with understanding negative numbers, and that's how I'll implement the ledger. But it's pretty easy to just go flip back and forth. So one of the ideas that I'm sort of getting across here now is that when you have units of like dollars and IOUs, those are what are called wealth accounts, in that they hold the current state of your wealth. And if you look at a balance sheet of a company or anywhere, it is just a big listing of accounts and how much money they contain and how much IOUs they contain. And you add them all up and you get net income, net wealth at the end.
What about receivables?
So receivables is money that it's in this first unit, which is this dollars amount, but it's not cash, right? It's an asset and it's wealth that you have, but you don't have it in sort of a fiat currency. And any sort of asset can be in that unit. It doesn't have to be denominated in that amount of money. It can be, my laptop is an asset, and that can be in the ledger too. And so it's a very abstract notion of money. It's really a notion of wealth, and that's why they're called wealth accounts. Now, when you spend money, great, you're have a ledger now, you can move things around, but what you're only tracking is how much wealth you have. What you're not tracking is why did the amount of wealth I have change? Right? If you paid for something, what did I spend it on? And so if you have a receipt like this, and you paid $8 for something, you might want to track what you spent it on in the ledger. And so this is where the sort of accounting equation comes in. And it comes from the idea that everything in a receipt has to add up to the total. And so you sort of decompose that and put that into separate accounts. And so now these accounts that are tracking your expenses are not wealth accounts, because they're not changing how much wealth you have, they're tracking why it changed. So you can see here that we've decomposed this receipt and stored it into the ledger as 4 separate entries. And what that allows you to do is, if you're adding more and more of these receipts, you can add more and more entries to the separate accounts and then track exactly how much you're spending on each sort of category of spending. And so you get to track both how your wealth changes as well as why it's changing. And so we call those, this is sort of I don't know if anyone's ever read academic papers on accounting. I have. But they call them momentum accounts. And the idea is they're called momentum because they track the change in wealth. And so an income statement, if you've seen that, is a big listing of these expense accounts, and we'll cover income accounts in a second. And it's just adding up all of those things, and they tell you, given a period of time, why did the wealth change, what was spent, and earned. Now, when you go look at a receipt, anytime you do a transaction and you spend money, the other party is receiving that money, right? And so if you think about the world in double entry ledgers, because that's how I do now, because my brain is a bit broken, everybody has a double entry ledger, inside them whenever they do and sort of any sort of economic transaction. So the same receipt for the restaurant works a bit differently, where it's the same numbers. The burger still cost $5, but instead of you paying for $5, the restaurant earned $5 for that burger. Now, what's interesting here is this tax is something that the restaurant hasn't earned. You've paid them some tax, but that money is something that's now owed to someone else. And so if you look at this sort of equation, you've got a different unit here with the sort of one IOU that's owed in tax. And so if you sort of put those together, when you put them into an equation, on the one side you've got wealth accounts that track how much my wealth changed. And so the restaurant got $8 in cash, and actually, but also added a liability onto their books, in that now they owe the government a dollar because they earned $1. And so the net amount of change was $7, which adds up to, okay, why did I get $7? Well, I got $5 for a burger and $2 for the drink I sold. So if you sort of put them side by side, the same receipt sort of adds up, looks different in two different ledgers. And so one of the important things about ledgers is they always have a perspective, right? They always are the accounting for someone's wealth, some entity, someone's wealth, and the same transaction looks different in different ledgers because those two parties have different perspectives on whether they lost or gained money, wealth in that transaction, and they're going to record the why differently, where a Russian might care about categorizing exactly the items that went into the receipt, whereas you might care about only that I spent some money on food, right? And so that's why there are so many sort of ledgers in the world, is because every person, every entity has their own view of what happened in the transaction, and therefore they have their own ledger. And so sort of, if you map all these different colors and types of accounts to the sort of 4 types of accounts that accountants use, you have assets and liabilities, which are wealth accounts, and then income and expense, which are momentum accounts. And then anytime you're adding to the ledger, you want to make sure that this equation gets followed, that if there is a change in wealth, it's always accounted for why there is, and if there's not a change in wealth, you don't have any change in the blue or pink accounts, but the change in wealth in the assets and liabilities all even out. So that even though you might have actually moved money around, right? For example, if you go and buy a house, in theory, your wealth hasn't changed. You just got something for the exact amounts that it's worth. And so the change in your ledger would be 0, even though money moved between accounts, because your house can be in the ledger and is worth something. So this is how sort of ledgers work today. I think it's sort of time that software sort of took over ledgers, and there's a lot more that we can do with ledgers than how ledgers work today, right? Where the way that we use ledgers today is pretty the same as how people use ledgers in medieval Italy, right? The data structure is exactly the same, and it sort of was constrained by the fact that it was humans who had to go and use the ledger, and they had to do it on paper. And our digital ledgers look like the same as those paper ledgers, but just scaled up. But now that we are like really at a point where most of the transactions happening in the world are through automated systems, not humans, you can solve much more interesting problems, add more capabilities to the ledger to solve those more interesting problems. I won't go through like all of these, but some of the sort of ideas that accounting researchers are playing around with, where so far, for example, we saw that a transaction only appears in a certain set of, in one account, right? Where if you say, I spent $5 on a burger, it's just in the burger account. But there's no reason why you couldn't have a multi-layered ledger where the same transaction can appear in multiple accounts simultaneously. And then you can have a sort of, you go from a data grid to a data block, if that makes sense, where you can choose how you want to look at your ledger at runtime instead of having your balances and what ledgers exist configured ahead of time. And so some of the problems that might be easier solved by adding more dimensions to the ledger instead of adding more and more accounts, or trying to sort of keep the same data structure the same and not sort of adding more capabilities to the ledger. I've talked to people who are using double entry accounting for not money, where people are looking at user behavior, and because those problems have some of the same properties as money, you can use a ledger to try and solve those problems. Things like, why did a user come in, go through a funnel, and fall off? There's always going to be a time and a reason they fell off, and that visit came from somewhere and is going to go somewhere. And so those same ideas mean that if you're tracking the state of where this visit went, a double entry system actually works pretty well for that. And you sort of are guaranteeing all those same things that, okay, we know what happened to every visitor, and every visitor that came in exited somewhere, and that we have a good way of like having a data structure to understand how things change in the system. And then a third idea that people are playing around with is the idea of momentum accounting, where if you think about a business, one of the things we really care about is the pace of change, right? How fast is the business growing or slowing? But ledgers, as they are today, give you a pretty static view of here is what the state of the business is today or on a particular date. And so one of the things you can do is to have a ledger that isn't denominated in just dollars, but have a ledger where the accounting unit is dollars per time unit, right? And so, a simple example is, we saw in a ledger, if you say, hey, we earned $1 million this year, and it's because we got this much from this product and that much from that product. Instead, if your ledger said, we are earning $100 million more this year than last year, right? So what you're actually accounting for is the change, the fact that it was 0 last year, 100 this year, 200 the next year, and so the rate is $100 million. And now you're trying to track, why is our growth that rate? And you could attribute it to this marketing campaign, you got product market fit, and those are sort of the type of accounts that you have is you're tracking, trying to track exactly why not just you have the money that you have, but why the amount of money you have is changing. And so if the next year you have a slowdown and you only get $50 million, where you go from 0 in sales to 100 million to 150 million in yearly sales, your accounting would say you're doing great, because your sales next year were better than this year, but the rate of growth has slowed, right? And so you want to account for why the rate of growth has slowed. And so there's a sort of, you can do that in a double entry ledger. You just have to, galaxy brain and figure out and work in units of dollars per unit time, and sort of tie that into your normal accounting system. And so these are sorts of ideas, maybe they work out, maybe they don't, but so we sort of are at the beginning of what ledgers can do, even though they're really, really old, because we're now at a point where software can really start going to town on it and not being constrained by the fact that someone is writing into a journal to try and account for all of these payments. So if you think back to our space company, what would be the ledger that they might implement for their business, right? And so you've got these 4 types of accounts where, if you go through the sort of flow first, a customer goes to the website and they just buy a launch. They pay $5,000 in cash and they sign up for a loan. And so the company's books needs to account for the fact that they received money from the customer, that they've now got a loan for the customer, and that's an asset for them, right? Because they're going to be earning money from that loan. But they promised a service in return for that amount of cash. And so they need to record the fact that they've got the money for this service, but they have not actually provided the service, and it's going to cost them money to provide that service. And so if it costs them $200,000 to launch, they need to make sure that they have enough money to provide that service when the time comes. And so you track that by adding that as a liability, right? Where it's an IOU that I need to make sure that whenever I do launch, I have enough money that I'm going to owe money in the future because I'm going to go buy a launch. When the rocket actually launches, what happens is this cost that's projected actually gets spent. And so the $200,000 they think they're going to spend now goes away because they just spent it, and that's recorded in this expense account here. And so you can see how this money is sort of moving through the system, where it goes from being an expected cost to being an actual cost. But throughout this entire sort of process, the company's actually earned $55,000, right? Where even though there's all this money moving around, when you take away what they earn from what they have to spend, that's being tracked here, where in this income account. And then once the customer launches, hopefully they arrive back safe, they start billing their customer for the loan. And then when the money comes in, they're not actually earning the $500 that came into through the door. Only some of that counts as profit. The rest of it is paying back a loan that they gave them. And so that sort of goes against this loan account. And so every month, this $250,000 goes down a little bit. And whatever extra is on top of that counts as their profit. And so if you want to figure out how much did we actually make from this whole scheme, you would go and look at these accounts and see what are all the transactions that are in here, and let's add them up. And that will tell us how much we actually earned. Okay, so that's sort of the conceptual part of the talk. And so if you have this ledger and you want to go implement it in QLDB, this is the logo, and it's a pretty interesting type of database where on the surface it looks kind of similar to a relational database. It supports Amazon versions of SQL, which is called Particle, supports joins, and it looks interesting. But it has some significant differences from a traditional relational database. The first thing is that it's schemaless. So Postgres also supports type of JSON documents and that sort of thing. This is similar, where you can store sort of arbitrary JSON documents, They're not actually JSON. Amazon thought, let's reinvent the wheel, and invented this thing called Ion, which has a lot of semantics as JSON, but it's stored in binary and has some extensions. To be honest, when you're using QLDB, you can just think of it as JSON until you shoot yourself in the foot and you realize, oh, it's because it's Ion, not JSON, that this thing is happening. But until that point, you can think of it as JSON, and you're basically adding JSON documents into a table, and then QLDB sort of adds in a bunch of features on top of that to make it more than just a document store. The biggest sort of difference with QLDB is that the most important part of the database is the journal. Now, most databases have this sort of two-tiered system where the underlying system implementation is a append-only log file, and then they give you like a user-friendly view on top that's relational or document database or whatever. But most of that sort of log file version of the database, which is just has sort of the changes, is really low level. Like, you'd only ever know that all of these databases are implemented as log files if you were like building them or trying to synchronize them across different clusters and that sort of thing. QLDB takes the idea of log file and sort of pushes it up to the API level. So, and it gives you access to that journal and says the journal is the sort of most important thing. So if you sort of look at, developer here, and she's sending in some queries into QLDB. So what sort of actually happens? The very first thing it does is it adds to the journal. And so, like before, we had those tables of just add 3 units, add 1 unit. QLDB sort of works the same way, where instead of going and changing the value of a row in a database, it just stores, hey, this is the change that was made. And every time a change is made in QLDB, it gets sort of added on to the log and hashed and sort of locked down. And so even if it's receiving a bunch of different transactions from a bunch of different clients, every transaction is in a strict ordering. If you know Postgres, it's similar to its serializable isolation level, where you know that the order the transactions came in was the order that they were committed into. And that every change to the database is a vector clock that tracks the sort of the version of the database, like globally, right? Where every change that's made, this is version 1 across all tables of what the data look like. A new transaction comes in. This is now version 2 of what the database looks like. And so instead of having sort of per document or per table versioning, you have got a version number for the entire state of the database. And that's a really interesting capability that you can use in lots of different ways. Now, a database that just stores the fact that a change was made isn't that useful. So what QLDB does is take that journal of changes and then puts it into a materialized view that looks more like a normal database, right? Where if you've made this sort of changes where you've inserted a document, you've updated it and then deleted it, you expect the database to look like this, where there is a document, and even though I've updated it, when I get that document, it should have the updated value. And so usually when you're querying and using QLDB, you're accessing it like any other database, but you know that this isn't the true form of the data. This is a roll-up of all of the changes, and the journal is what's really storing the database. And you've also got a history table, because that's easy to build, right? Of saying, okay, here is the current state of my document, and here is a table that has every revision of that document. And so you can query both of those using Particle, which is basically Amazon's version of SQL. And the other part of it is that because QLDB is super specialized, like its SQL syntax is pretty limited. It doesn't support like all of SQL. you can't do lots of things in it, and some of the things you can do are really inefficient, and there's big warnings in the documentation saying, hey, don't do this. And that's why it's really important for that it supports event streaming out, so that you can take all of the changes you're making to the database, stream them out to a different system to get some of the capabilities that are missing in QLDB. And it's sort of similar to a Dynamo-like philosophy, where it's going to make a bunch of trade-offs to really specialize and give you a bunch of capabilities that you couldn't get any other way at scale. And then so it's up to you to sort of say, okay, if I'm getting this sort of superpowers over here, I still need to do the other things it doesn't do. How do I go do that? And you would use the event streaming to maybe push it into a different database that has those capabilities. You might have another database that has complementary capabilities to QLDB, where it makes the opposite sort of trade-offs. So you have like two databases that sort of together give you a full set of capabilities you'd expect from a database, but each of those can scale much higher than a normal relational database that gives you sort of everything in one box. And that's a sort of trade-off you make, because to get that level of scalability is your architecture is more complex because you have multiple databases. Each of them are specialized, but really good at what they do individually. So going back to our example, we had the sort of ledger entries. What would the sort of database schema look like for that? Obviously, maybe in a production environment, you might have a few more rows and columns, but here is sort of the really basic sort of entry schema, for a ledger in any sort of type of database, where we have accounts, and they're really simple. They just are sort of a name and a balance. Those accounts contain lines, which were like the $2 I spent on a burger, the $5 I got in cash, and then those lines are contained inside entries, because you want to make sure that whenever you add a set of lines, they can be treated as one object, which was an entry, and that entry is balanced. Some of the more sort of interesting things that are going on here is that accounts actually have a balance on them. And you may or may not implement it this way sort of in real life, but it's actually possible to do it in production like this, where when most people implement a ledger in a normal database, they have a similar sort of schema where they have some lines in there, a table for lines, and they put them in. But when they want to calculate a balance, they'll go and usually do a query for, ask for all of the lines and do a aggregate across those lines to get the balance, right? And the reason you don't store a balance in that type of database is because it's harder to make it sort of transactionally consistent. And if you do, you have scale trade-offs. Every update is updating the same row, because you're trying to update a balance every time you make a change. But one of the things that you can do with QLDB is, because of its sort of way it supports transactions, you can update a balance in line with lines, and I'll show you some of the code of how that works, and be guaranteed that this balance over here will never be out of sync with the lines that you add. The other thing that we have here is an idempotency key, super important for ensuring that if you have a system that's adding ledger entries, you never record the same transaction twice, because it's an append-only system. If you do it wrong, you can't undo it. The only thing you can do is to add a new entry that corrects the one that was previously made. But things go wrong as a fact of life. US West 2 in AWS went down a couple of weeks ago, and we had people in production with calling our API, and connectivity between our servers and our database was just broken, where some of them went through, some of them didn't. Partial stuff was happening, but you sort of expect that to happen sometimes, right? And if you build for that, then when the system comes back up, it'll heal itself, right? You have queues and everything there, things that get retried, things heal themselves up, and you can carry on without having to worry about, well, we might be in a broken state and our recovery might not be good enough to get us back to a state where everything matches up. So I'll also look at how would you implement an idempotency key in QLDB, and that makes it like really easy to do something like that. You also notice there's no sort of primary key in here. So this is where it's like different than a relational database, a traditional one where each document you insert into QLDB has a document ID. And that's basically what you use as the sort of the primary key, but it's generated by QLDB. You don't get to pick it, you don't get to use a composite key or anything like that. And so, I mean, you can if you want, we can go through that, but it's really designed to say each document, each sort of entity has a system assigned ID. And so that's sort of like not in the schema because it's sort of implicit that every document has an ID. But when you have this relation between like these lines to over here, from this document to that document, you would have an array of document IDs as the sort of foreign key into that relationship. So here's what our lines might actually look like for that first use, for that first ledger entry, where the customer goes into a website and buys the launch. And this is super simple where we have the 4 amounts that come in, and this sort of ID would be the document ID of the account document. And we say we want to add in these 4 lines to these 4 accounts with these amounts, and all of these lines are sort of under this entry which has this description. And so this is sort of just a sort of input data, and then we'll go and look at how we implement a function that can take this input data and create all of these entries, update the balance, make sure it's idempotent, and sort of basically work the way that you're supposed to, that we think it should. So what does this function look like? So this is implemented in JavaScript. It's pretty close to what you would actually write and do. And so we sort of go through it. So you get a driver. This is the Node.js driver, but all of them have a very similar set of semantics, whether it's like Java or Python, etc., where QLDB itself, the raw API is a REST API. And that that API is not sort of what you'd expect in terms of you don't just send it a query. What it has is the idea that you can start a transaction, and so every read and write to QLDB is inside a transaction. And so when you use that REST API, you're opening a session, you're sending it commands, and we'll go through some of the commands that you can send over here. And then at the end, you should have finished the transaction. And those commands, you don't have to send them all at once, right? Where you can send them, you can send a command, do some work in your code, send another command, do some work in your code. There's a 30-second timeout on those commands, on those sessions, so you can't keep them open that long. But that's usually long enough that you can read some data, do some calculations, and then send it back. And we'll talk about how that is transactionally consistent. In this example, we're doing the very first step, which is inserting these lines into the lines table. And so that's what it looks like, where it gets the input for the lines, and it runs this SQL query, particle query, which is insert into lines, and because it's document-based, we've given it an array of documents to insert into this table. This sort of function inside here is inside this like execute Lambda thing. And this is a wrapper that opens that session, allows you to send in commands, and then when this function returns, is QLDB automatically closes the session and commits your transaction. Since this is a pretty simple insert, we're not going to expect to see anything go wrong in terms of transactional consistency. You should be able to do as many inserts as you want, and you should never get a conflict. Now the input statement gives you back the IDs for the document, and so we just need to do a little bit of boilerplate here to sort of reconstruct. If we inserted these documents and it gave us these IDs, we want back an array of documents that has the ID and the data sort of side by side. That's the most useful thing to give back to the consumer of this API. And you usually take all this and put it into a few boilerplate functions and just wrap the library so that you don't have to worry about doing this sort of stuff every single time you make a call. So then the next step is So if we have this sort of stuff going on with inserting the lines, we just sort of export that into a function, and that's basically what's going on here. Entries work very similarly, right? These are just inserts, and now it's getting interesting, where we want to go and update the balance on the account. So the first thing we do is iterate through the lines and select all of the accounts that we're going to update, and then we make it into a map or dictionary just to make it easier to find the account when we want to go update it. And so here we go and select all the accounts we want to update, and then we update those account balances. So it's set balance to this new balance, and this new balance is the old account balance plus the amount in the line. So this is the most naive thing you could do, and this is what sort of theme is with QLDB is. This is super simple, almost pseudocode, but it's pretty close to production quality, right? In terms of if there is, by selecting this set of accounts, what you're doing is you're adding that set of documents that you've selected into the transaction scope and making sure that nothing else, no other transaction will update those account balances between you reading them and you writing them. And the scope is sort of larger than that, where here we're selecting specific, we'll talk about in a sec, or when we talk about item potency keys. So if you're running these transactions, in a system, there are going to be conflicts that happen, right? Where two people buy at the same time, you want to update the same balance, and that's sort of expected to happen. It uses optimized concurrency control, and the reason that you wrap these updates in the execute sort of lambda is that the driver has automatic retry built in. And so if you get to this point and you're updating the balance, and in between you reading and you writing, someone has updated the balance, it will cancel the transaction and then automatically start retrying from here. So then when you reread those balances, it'll get the new updated balances and set the balances sort of correctly. And so you don't have to write any of that retry code. It's just you just say, here's what I want to happen, and QLDB will retry and time out and sort of take all that for you. When you instantiate the driver, you can configure all this stuff more nuanced, in a more nuanced way, so that you can figure out back off times and retries and all the sort of things you'd expect. But out of the box, it works pretty well, where you'll never have a write that is not transactionally consistent. But if you write bad code, you might have a system that is having too many conflicts happening because you're putting too many things into your transaction scope as being locked. So this same type of system where we have to say, I want to make sure that nobody updates the balance when I write it, is the same sort of techniques that we use to implement item potency keys, where now we've sort of moved all that code by updating balances into here, and now we're sort of doing a check to say, okay, every entry I add to the ledger will have a unique and stable identifier of some kind. And so we're checking and we're querying the database to say, okay, is there an entry already in the database with this item potency key? And the difference between this select, where we're doing selecting by an item potency key, and this select is that here we're going by document ID. And so now we know that the specific document that we want to go and get. Whereas this is using an index, because it's just on the document attribute, not the document ID, which is sort of indexed implicitly. And so this is one of the sort of constraints of QLDB, is that it only supports 5 index properties per table. And so you sort of need to carefully design what your indexes are going to be, and you can't create them after you can create them after you put data in there, but if there's any data in there that uses those attributes, then you can't create the index. So sort of similar to DynamoDB, you need to do your data modeling upfront to make sure that you're storing your data in a way that you can query it efficiently. And querying by a non-indexed key is sort of bad in every database, but it's especially bad in QLDB because of its transaction sort of capabilities, where if you try and query for for an attribute that doesn't have an index, it'll actually lock the entire table, and so any update to that table will cause a conflict, and you're going to get pretty bad throughput. It's probably higher than you'd think. You can run quite a lot through full table locking these days, but you definitely don't want to sort of code that in. And so these sort of queries over here are the only 4 ways you can query the database in an efficient way. And I mean, I guess it's nice not to have to learn SQL. I didn't know before. I had to learn of these things. And they cover the most common use cases. But knowing that these are the only queries that you can make efficiently sort of means this is how I have to lay out my data to be able to use these queries to get the data that I need. Yeah.
I have 2 questions.
Yeah.
Basically, just trying to map
Yep.
my head on how I would do it with SQL. So in your first one, where you were updating the account balance, does QLDB have the equivalent of triggers on a table? Because in that case, like whenever I add a line, I want to update the available balance, and I'd rather do that, essentially in the database where I don't need another call, not guarantee that code will always execute. Does that exist?
No, it doesn't have like triggers or stored procedures or anything. It's got the events, which are going to be eventually consistent, right? Because it's going to be a separate system running those, or you run it inside your own code base.
And the other question related
Yeah.
to that, not to like a SQL concept, is you have to set your indexes into the item potency key, so they don't have the concept of the index in that case where it would automatically fail if you insert that item potency key. You always have to check it yourself.
Yeah, right. And so it's same sort of ideas of you can implement it, and it's not really a problem. Basically, it's to go and do that if check in your code, and it's just it tries to have a small API and give you the sort of tools to go build that sort of things yourself, and then they'll just figure out how do we make sure the small API scales really, really well. Very cool. Any other questions? Cool. Yeah. So when you're doing a query, these are the sort of only ones that you can do, and you basically are doing it by either document ID or an indexed operator. What they don't have, which is a feature in QLDB, in DynamoDB, which I quite like, is that in DynamoDB you can refuse permission of your code to invoke a scan. QLDB lets you do a scan, and there's no way to stop someone doing a scan. And sometimes it can be hard to tell if you're doing a scan or not, because obviously these are the sort of simplest versions of those queries, but there are more complicated versions where real code would have more complex queries, and you're like, do I fit into these patterns or not? It's not entirely sure. And the best way to understand like the load you're putting on the server on your queries is that anytime you make a request, you get back in the wrapper of the data from the request metrics on how many IOPS you're using, what the latency is, and how many items were scanned to make this query. And so if you're like doing this sort of type of lookup, you would expect 2 items were scanned to find these 2 items, right? If you have, it's 1,000 IOPS were used for this simple thing, we're like, oh, I probably forgot to index this attribute. So the other thing you can do is to query history. So if we go, remember, back to the diagram that we had with the journal, created materialized views. So far we've been accessing the usual materialized view of what's the current state of my database. There's another materialized view for history where you can just, this query will basically just get the entire history of that document. And this is sort of what it looks like, where this data is what would be in this in the normal table if you looked at that, but it also has a bunch of sort of metadata in there. Some interesting things are, so every document has a version number that gets updated every time you touch it. That's built in, which is nice. And then every version of that document has a hash, and all of those hashes, I won't talk about it too much, but all of those hashes can add together to make sure that, for you to verify that Amazon, for example, didn't change the data in your database, because it works like a blockchain where every transaction includes the hash of the previous transaction. And because of that, this sort of sequence number is the sort of index of that block onto the journal. As I was saying before, how there's a monotonically increasing version for the global state of the database, and that's really useful when you're streaming things out of QLDB into other systems. You have a vector clock that you can use to make sure that you can run updates multiple times. You can, for example, if you have we're talking about this. If you have a stream coming out of QLDB into Kinesis, most systems will give you at least once delivery on those messages, which means that you might get an event into QLDB, from QLDB into your Lambda function or whatever's processing your events multiple times. And so having both the document version number and the global database sequence number is what allows you to take those events and dedupe them, do optimistic concurrency control, whatever you're doing with the other side of the database. Sort of that gives you a really nice way of solving this distributed concurrency problems that you kind of create for yourself by using QLDB. So QLDB sort of out of the box supports Kinesis as an output for all of its events, and on that stream you get sort of 3 types of events: control records, block records, and revision records. Control records are really simple. They just say, hey, a stream started and a stream ended, timestamps, and that's, you don't really use it day to day, but with a QLDB stream, what you can do is, if you have a stream running into a Kinesis stream and you're like, yeah, that's like my day-to-day thing, you can create a new stream out of that same database and say, can you replay your entire journal from the beginning, from X point in time, into another Kinesis stream? And so that's really nice in that that's built in, where, you can, from the beginning of time, replace your entire database into a stream and do something with it. If you want to archive it, if you want to back it up, if you're migrating the data to something, you can just go in and say, just every event you've ever sent, just replay that. And then for that type of use case, a control record is useful, but that's like pretty niche usually. And then you have these two types of records, block records and revisions. And blocks are a log of transactions. So when we did the execute Lambda, we started a session and we send all these commands. A block record will basically contain those SQL particle statements and to say, here is what each transaction did. And then revision records are a log of doc version. These are sort of the most familiar ones that if you're used other sort of change data capture type of systems, that just gives you, for each document, anytime it's updated, it'll give you a version onto the stream.
So if you were
Yeah.
trying to keep a data warehouse in sync, would you primarily use the revision records to update that as you went?
Yeah, so that's exactly right. So most of the time you'd use, like, these are the most useful, they're your data right now. If you're trying to keep a data warehouse where you wanted to replicate the exactly the entire history of that document and exactly what happened and do sort of really like audit style data warehousing, these might be sort of interesting in terms of, these are like the nouns. Here's what happened to the nouns, and here's what happened to the verbs. So it's probably easier to see if I actually show you what they look like here. Where a block record, for our type of use case, they might look something like this, where we did a select for either potency key, we inserted some lines and entries, and then we updated these balances. And then in here is actually the documents that we sent. So the lines that we send, the updates that we sent in here. And so this sort of gives you like a full audit of what happened in your database, every statement that was run, including reads. And so that's like a weird thing where, for me at least initially, was that even to do a read, it's a transaction. And that read will appear in your log, as a block record, so that you can just have all the activity comes in through there. And then this is
Is there
yeah.
any, I don't see it there, but is there any like security audit in there, like a user that ran the query or anything else that you would use to attribute it back to what caused that to run?
I'm not sure actually. I've not looked at this gigantic JSON block closely enough to exactly know what it sort of, you have set of IAM permissions, that you'd expect on QLDB to, allow different writes and reads, and the different sort of buckets of IAM permissions mapped to different types of SQL statements you're allowed to make, based on the principle that's creating, talking to QLDB. Yeah.
Can you execute any read statements outside of kernel, or is it every read statement you do, like, update that or
Yeah, so read statements, unless they make a change, don't update the sequence number, they don't rehash. But they do get added to this block record. And so that is the theme in general. QLDB does stuff where you're like that can't be efficient, or that, you would be crazy to do it this way. But it kind of works out because of the trade-offs that it makes. And so, because you don't, for example, I don't talk about pagination, for example, because it doesn't support pagination, right? If you want to do, you can't do a limit on your query. That sort of comes down to, it's hard to optimize for those cursors and everything, especially if every transaction, every read is a transaction. But that's why it's really important to then say, most use cases probably need pagination, and so you really want to be taking that data into another database where you can do that sort of more, broader sort of querying versus just this is my, I always forget, OLAP, OLTP, which one it is, but this is my operational database, and then my reads come from somewhere else. And this is pretty similar to the contents of the history table. that we had, where here's the revision for this document on this account, and you have your version number and your sequence number, as well as the sort of transaction ID that you could log into your application logs, so you can correlate, what was the transaction in your logs that created this revision change. Yeah, I mean, that's sort of pretty much the end. We've talked about some of this stuff. Here are sort of a couple of other things where it sort of works like Dynamo in time, like serverless, as opposed to like Aurora, where you don't choose any capacity. You just start putting data in, and it charges you bytes stored and I/O operations. Now, because it's a journal that never we can never delete data. The journal storage gets charged sort of into the future, right? Where if you add some documents and you have some storage in the journal, you'll get charged for that. Even if you delete the document out of it, it's still in the journal, and they charge you for that journal unless you delete the entire database. That's where it costs a bit more for storage. They don't charge that much for journal storage. We use both Dynamo and QLDB, and it's about the same. And so, for some use cases, Dynamo is great. For others, it's not great because it charges per byte, and QLDB is the same. I've been talking to the folks at Amazon about, some of the typical questions that you would have around, can I really run my entire ledger on this thing? And so they said, this is something they're obviously working on. But right now, as of a couple of months ago, you can support 2,000 to 3,000 transactions per second on a single ledger, which is pretty good for most use cases. And the latency is again similar to Dynamo in that it's 10 to 30 seconds if you're inside Amazon, EC2, ECS, Lambda, and calling out to QLDB, and it's included in time to go from your client into the database, HTTP round trip back. Because it's HTTP, all that stuff is HTTP2, so it's using multiplexing and connection pooling and all that sort of technologies, and so that's why you don't need to have like the database pool that you normally have if you're talking to Aurora and stuff. It just uses the HTTP connection pooling to sort of do all of that, which is a nice advantage to not have to worry about it at your application layer because it's already taken care of at the network level. And then just to sum up, the theme of the talk has been it's got a interesting set of capabilities. You can get to a production quality database super easily because all the stuff it has built in. But it does make some trade-offs. You do plan your architecture around those trade-offs. It sort of allowed me to get from 0 to a full production ledger pretty quickly, and there are ways of doing all of this sort of stuff in Postgres and other types of databases. It just has this stuff sort of built in, and what I showed you is pretty close to what my production code looks like, and that's sort of the real sort of what you get for using this type of database. And a typical trade-offs when you buy versus build, where they say they scale. So far, it's scaled, but I don't have any control over whether it will scale because it's all a managed service. But if Dynamo is any example, it'll probably scale fine, unless you do something wrong, which is easy to do sometimes when you have a complex data model and all that sort of stuff. So I think that's pretty much the talk, and if anybody has any questions, yep.
Is it similar to Dynamo in terms of how replications handled? Does it automatically replicate across like ACs, or do they have region replication?
Yeah, it doesn't have cross-region replication, but it does have AZ and stuff, and that's all hidden away from you. Yeah.
Does the cost basically grow linearly as you store more data?
Yeah, pretty much. yeah, like if your um, writes aren't like scaling hugely, or your reads aren't scaling hugely, it'll just slow. The more data you add, the more you pay per month, and you're sort of paying more per month for the previous data you added to be in the journal. But they charge differently for what's in the journal versus what's indexed into the materialized view. And so if you're adding data and then deleting it afterwards, it'll be in the journal forever, but at a much lower cost than if you kept it in the index storage. Cool, yeah.
Have you had any issues operationally with it? Be it just availability, odd latency, any other things that just been wonky about using, or has it been pretty stable and reliable?
I mean, like it's been pretty stable and reliable in general. The issues I've had are generally things like it was an early product when I started using it, so some of these capabilities around understanding, am I doing a scan or not? The documentation wasn't, it's gotten better over time, shall we say? And so, some of those issues, but in terms of actual operations, the only time sort of it went down was when US West 2 went down, and like everybody was down, and that was, nothing that is, I think it was an elastic load balancer issue, and so everybody inside AWS was affected, and so was everybody who was using US West 2 a couple of weeks ago. But in terms of that, the database itself, it's been completely fine. And we're running a few $1 million of payments every month on QLDB, and so it's not a huge load, it's like as we max out of maybe dozens of transactions per second in a burst, and that's been totally fine. And we have logging that says, hey, there's been OCC conflicts and stuff, and that's expected sometimes, and it just carries on. Yeah. Yeah, so if you read from the materialized view, it's strongly consistent, right? And then, so for us, we then take some of that, take the event stream, and then all of our aggregations are, Lambda into Dynamo. And so that's like a typical what you expect of a second, maybe if you to get all of those aggregations into Dynamo. But depending on what is being read, we read straight from QLDB. If it's like, hey, I want to get this particular row, basically, that goes straight into QLDB. But if it's an aggregated or historical data, that goes against Dynamo. And yeah, like it just depends on what the latency is as a consumer of the Kinesis stream. Yeah. Mm-hmm.
In terms of, is it really like a blockchain where only grow? Is there a RFI ticket essentially that, 5 months or 7, 10 years, have this whole data that really never need to access again beyond just export to
Yeah.
refund basically. Like it essentially start the whole thing over, because otherwise I'm paying for, you said it was lower, but
Yeah.
paying for that whole storage cost that only grows forever. Or like basically something like, okay, I'm going to go to the database, essentially start from an initial state based on my archive learning, have essentially chunk off the beginning of the journal at some point.
Yeah. Today, I think you would expect it to use that stream functionality to stream that data out to some other database, maybe wipe that, start a new one. I'm sure that's something that they're working on. Like one of the things that in there is that you see that they currently support one strand in there, and so I'd expect one of the things they could add with multiple strand support is the idea that, okay, this strand is now old, so let's archive it or export it out, and you can still use the same structure, but now it's been partitioned away. But yeah, they haven't added support. I don't know what an extra strand will do. It's just in there as a random identifier so far. But it would make sense they would add that sort of stuff. But yeah, I mean, that's definitely a thing to be looking at. Yeah, yeah. Yeah, I mean, we can talk about that in that. As a SaaS provider, we don't really know the loads that our customers are going to put on. Like, we know it's going to be high or low, but are they going to be like reading this, one document a huge amount, or like all over the place, and how bursty it is going to be? Like, it's hard to get a judge, especially as a startup, of you don't have a customer profile that you go after, right? And so by picking something like Dynamo and trying to be as good as possible about partitioning, we can sort of try and make sure that whatever read load that we get is consistent. And like Dynamo is kind of crazy because the more load you put on it, the faster it gets. Yeah, I mean, the sort of, I guess we wouldn't do this. The philosophy that we generally have, it's serverless. Our entire architecture is serverless, and so we don't run anything locally. There's a framework we use called SST that allows us to run everything in Amazon. So you have maybe a UI, it calls an API that's inside Amazon, which calls a Lambda. And the SST framework has that Lambda open a WebSocket connection back to like my laptop. My laptop services the request and then sends the response back up again. And that's a really nice experience because then all of the code is running on your laptop, but it's like interacting with like real SQS and real Dynamo and all the real services. And it's kind of crazy because you can like run a remote API call, but set a breakpoint for that thing locally. SST, so serverless stack. No, that's it's built on top of. It's basically a wrapper on top of CDK, if you know about that. So CloudFormation is like the YAML-based, nice. Well, not nice. It's it's CloudFormation, and then like CDK is Amazon's sort of new version of CloudFormation. That's instead of being declarative, it's code-based. And so you write, JavaScript or Python or whatever as your infrastructure code, and then it does the same thing as CloudFormation, but you have a lot more flexibility because it's code-based. And then SST is an abstraction on top of CDK that sort of makes it easier to use because Amazon don't always have the best documentation or DX in mind when they develop some of their things. Cool. Any other questions? Okay, yeah, I think that was great. I'll be up here for a while. I'll be walking around if you have some other questions. But yeah, thanks for coming. Hey. Oh, there's.
But I was really actually right. So for the QLDB, does it mean like we can also define it? AWS CDK.
Yeah. Yep. Yeah, CDK